So let's do this part. Let's see how we do with this. Paul is training for his town's 3-mile race. He needs to run at least 1 mile per day. If Paul runs to his grandma's house, which is 5/8 of a mile away, and then it's to his friend Aaron's house, which is a ½ mile away, will he have trained enough for that day? Will he have trained enough for that day? Let's break this down and see. He needs to travel. His town's 3-mile race needs to run at least 1 mile per day. If Paul runs to his grandma's house, which is 5/8 of a mile away, then to his friend's house, which is 1/2 of a mile away, would that be multiplication or division or? It's addition. Katie? What is it? He'd only ran a mile. Another 1/8 of a mile. Okay. So he didn't because he would have only ran just over a mile. But look what the question's asking. What do you think, Kenzie?
Well, he at least needs to run 1 mile per day. So it would be what happened before 8. So if you added 5/8 plus 4/8, it would equal 9/8. So that's the number of that fraction, which will equal 1 and 1/8.
Yeah.
He would have already ran a mile.
So if he was talking about training enough for, if it didn't say that he needed to run more than a mile a day or a mile a day, you would have been correct. But I just pulled those out there. I highlighted those so you recognize the key words in that. We're saying we're only needing to run 1 mile in a day. At least 1 mile, exactly. So that means he could run 50 miles if he wanted to, and he'd still be training for that 3-mile race, right? That'd be a lot of running, yeah. So, as you guys noticed, this could be multiplied by 4, and you guys are, a lot of you are probably able to do this in your head by now. 9, 8, 1, and 1/8. So the answer is yes. He ran enough he ran enough. He ran 1 1/8 miles. There. Hey, it's early. We gotta wake you up. So as far as the modeling multiplication goes, whoops, wrong button. As far as modeling multiplication goes, I want to show you what's happening when you multiply a fraction by a fraction. When you multiply a fraction by a fraction, okay, come on. There. So we have shade 1 square, partition vertically to represent 3/8 shown below in pink. See how that's 3/8 shown in pink? We have 8 of them separated out just so show you sections. So we have 3 of the 8 that are done. Then we have another shaded square that represents 2/3 shaded in blue. That's not a frowny face. That's a close parentheses, then a semicolon, or then a colon. So then do blue. Oh. Then look what happens when we take the 3/8 and superimpose it. That means like put it on top of the 2/3. Look what is double shaded here in the lower left corner of that, all those spots. Abby? 6. 6 of the, how many squares are there now? 6 out of the 16 are shaded in, and that's actually the correct answer, 6/16, so you just have to reduce that then. Okay, so that's what's happening when you multiply a fraction and a fraction. It's the part that lands on top of themselves, on top of others. So let's do it together. We have 1/2 times 1/3. So we are going to model that by doing this. I want you to create a square. And another square. This is more like a rectangle, sorry. You can have it a square, you can have it a rectangle, but just not a circle this time. Okay. And I'm going to shade in 1/2 of this. And you can just keep your pencil and just do it lightly. Sorry, thank you. Thanks. So here's 1/2. Then we're going to do 1/3. I'm going to do it this way. Okay, just put it down and use this sharpener if you want. Okay, it's the third time you've dropped it. If you can't hold on to it, I don't know why he would have had it anyway. Okay. Just put it away. Then we have 1/2. Whoops. Say 1/3. I'm going to do highlighter in blue. So I'm going to do 1/3 now. So there's 1/3. Now if I were to superimpose onto the other one, I would have half of it be like this. And this would be like that. Now, how many of those are filled in? Yeah. 1/6. Yes. So we have 1/2 times 1/3 is equal to 1/6 because there are 6 of these boxes now, and only one of them is filled. So the part is 1, the whole is 6, and we have 1/6. Those band and orchestra kids are loud, yeah. Yep. I just wanted to show you how that is the way that it is. So this is like the very beginning of it, so we can just establish that knowledge, and you are very correct. I'm going to go 1, then 2. No, I don't want you to go during passing periods. I don't want you to be stuck out there with the people that takes longer. Yeah.
Why wouldn't you use the fraction boxes that aren't filled in?
Why wouldn't you use them that are not filled in? Because when you have a fraction, you have a part over a whole. And the part in a fraction, when we're representing it, visually, the part is the used portion. The whole is the entire thing that's chopped up. Okay? In this situation, our part is the double shaded in, and our whole is 1, 2, 3, 4, 5, 6. Cool? So it's already simplified. We can't simplify 1/6 anymore. Do you agree? Good. Now let's do 2/6. 2/6 and 1/3. 2/6 and 1/3. We're going to do rectangle again. Rectangle again. This time we do a third rectangle. I'm going to cut this into 6ths. Didn't mean to do that one. How do we? Let's do our 6 together. How are you guys chopping it up? How'd you chop it up? So you did all like spaghetti?
Yeah.
Did anybody else do it like how we had our solution last one? Straight down the middle, then horizontal lines? How'd you do it? Like that? Okay. So that's going to be very similar to what you had, most likely. Then we have 1/3. That's not going to work. That's not going to work like that. I'm going to do it this way. So now we have to do 2/6. So I'm going to shade in 2 of these 6. Then I'm going to shade in 1 of these 6ths, or 1 of these 1/3. So when I superimpose those, I have my 1/3, 1/3, and then, oops, darn it. Third. It's halfway down that way. And these ones are shaded in. This one is shaded in. And what is being double shaded in, Hunter? 1/6. I disagree. How many? I guess I can make this bigger. So this is it zoomed in. I had to remake the squares that I've done. Let's see here. Nope, not that middle one. Not that middle one. It's to visually represent it. Believe me, this section is going to be super easy. Super easy. Okay, we have this shaded in. We have this shaded in. All right, now, how many are shaded in? Katie?
There's
1/9 shaded in. You are correct, because look, 1, 2, 3, 4, 5, 6, 7, 8, 9. So solution is 2/6 times 1/3 equals 1/9, and it's already simplified. Let's see if you did it a different way and accidentally got the right answer, or if you did the different way and you got it.
I got 2/18. Because I did it this way, I got 2/18. Me too.
Well, how did you get it 2/18 if we're just counting how many are doubled up? Kenzie?
If we have problems on the test like these, we have to show our work with the boxes.
Sure work. No, we're just going to do the problem. We're just going to do the problem. I'm establishing how this works in this one. Okay, let's skip down to the last one so we can get started on our homework. Kylie had a ½ bottle of juice in a bottle. Boom. I'm going to stop right there and go 1/2 liter of juice. Stop making noises with your mouth. It's fun to do. Do it by yourself. She drank 3/4 of the juice that was in the bottle. How many liters? Okay. how many liters of juice? Now, one might just look at this and be like, okay, I'm going to do subtraction. But it's not subtraction. It's multiplication. Because, A, we're doing multiplication right now. So she drank 3/4 of the juice. How many liters did she drink? So we're going to multiply this by 3/4. Okay? We're going to multiply that by 3/4. Now, the beautiful thing about multiplying fractions is all you have to do is just multiply straight across. 3 times 1 is 3. 2 times 4 is 8. Multiplication is the easiest one that you'll do. Yes, ma'am?
When I look at it, I think that it would be addition. That one, too.
Nope, it would not, because she drank 3/4 of that juice. She had, how much of the bottle did she drink? How many liters of juice did she drink? Yeah, she started off with a half. So, for example, you have, well, imagine your bottle of juice that had a half a liter in it. So you have your bottle of juice. Okay, we'll say it's a 1 liter bottle of blue juice. Okay? And you drank 3/4 of it. So you drank 3/4 of that. It's asking, of that original half, how much of the stuff do you have that you drank? You drank 3/4 of a half, so we would have 3/8. And we could model it as well. We had half, stop. We'll make it orange juice. Or lemonade, okay. All right, so there's our half liter. We drank, how much was it? 3/4 of that. So we need to get 1, 2, 3, 4. We drank 3/4 of it. So of that little bit, we drank this much of it. See how the part that's orange is the part that we drank of that half? Okay? So we drank 3/8. We drank 3/8 of it because that's how it's modeled. Does that make a little bit more sense now? Okay, because the original was a half. Yes, sir? We drank 3/8 of half of a liter because we started with the half. How many liters of juice did she drink? Oh, yes, you're right. You're right. No, that doesn't seem right. Me answering, saying no at first. She drank 3/4 of the juice that was in the bottle. No, she would just, it would be less than that. As far as the whole thing goes, she drank, that's how much she drank that time. That time she drank 3/8. Yeah, liters. She drank 3 liters. You're right. So, in conclusion, this is how you multiply fractions. To multiply fractions, write this down at the end. To multiply fractions, just multiply numerators then multiply denominators. and then multiply denominators.